Hi everybody, my name is Richard Oberdieck, and in this tutorial I will be displaying the functionalities of the problem generator in the POP toolbox. Now, the problem generator is really one of the most powerful functionalities of POP, and it allows the user to generate random multi-parametric programming problems of arbitrary size almost instantly. Now, the four problem classes that it can generate is multi-parametric linear programming, multi-parametric quadratic, multi-parametric mixed integer, multi-parametric mixed integer quadratic programming problems. And the way it does it is basically it randomly generates an objective function, a well-scaled objective function, and then it generates a set of constraints, and each constraint is randomized. And in order to give you a bit of a better idea, let's jump into it. We'll open the toolbox, and if you click on generator here, you can see the interface with the generator using the GUI. Now, the way it's generated, as you can see here, you have lower bounds, you have an upper bound, you have a range value, which is your scaling parameter, you have borders, shifts, and so on. Now, all of these things are explained in much more detail in the problem in the user manual, and in fact in table 2. And together with the paper, this should give you a pretty good idea of what exactly is happening in the function. Now, specifically, what you can do using the interface is you can select one or multiple problem classes, doesn't matter. You define your parameter size, which can be anything from, say, 1, 4, 6, which now means that you will generate an mp-MILP or an mp-MIQP which has 1, 4, or 6 parameters. Let's say we want to have 2 to 10 continuous variables, and we just want to generate one problem. Now we hit the random generate problem button, and we want to obviously have a variable name, and now this problem has been successfully generated. Now, if we want to see that everything is checking out, let's switch over to the solver menu, and we can load this in. And as you can see here, we have 10 continuous variables, we have 1 parameter, with 31 inequality constraints and 0 quality constraints, and we have an mp-MIQP. So all the functionalities that we set out right here have been in fact carried over. Now, in order to ensure feasibility of the problem, what we actually do is we solve a feasibility LP for the constraint set when we generate it, so that only feasible problems are returned back to the user. The downside of that is that if the problems are very specific, for instance, if you specify only a very few number of constraints, this might lead to infeasible problems. And so it will go through a number of iterations. It will go, in fact, through 1,000 iterations and try to generate 1,000 random problems before it will tell you that you should change your problem size. Now, what you can use the problem generator for, in its most, let's say, versatile form, is that you can generate problem sets. So, for instance, we can now type in here 50, which means we will generate 50 problems, which will be either, each one of them, either mp-MILP or mp-MIQP, either have 1, 4, 6 parameters, 2 to 10 continuous variables, and those will be generated, as we will see, almost instantly. Now we hit the button here, we again maybe say 2, we click OK, and now this has been generated. And to give you an idea, again, let's look at the solver. We select the second one, and this is an array of 50 problems, okay? And now to see that how this looks like in the command window, let's have a look at random problem 2. This is, as you can see here, an array of 50 variables, and each one of them has all the things necessary to be solved by POP. Now, if we go back to the POP window, as I said, there is all these other functionalities that you can change. Note that they are not fixed, neither of them, to predefined values, but they're more each of them is a parameter that's in itself randomized. So you have a random problem generator with the parameters that define the problem being also randomly generated. We did that to ensure that the problems don't have any type of structure at all. Now, in terms of the direct use using the command window, the problem generator is available through the function problem generator. So if you click help here, then you can see this is the function. You can use it pretty much identical to the interface, which means that, as you can see here, you have three inputs: class, size, and options. So let's say your class input is, let's just recreate what we had in the interface, either an mp-MILP or an mp-MIQP. You say the size of x should be 2 to 10, and the size of t should be 1, 4, or 6, and then we generate the problem. This is now one problem that has been generated. If we would like to generate more than one, we have to specify that in the options. Options problem number equals to 50, and then we'll add that right here. And as you can see, we've now generated 50 problems. Note that these 50 problems are now different from the ones we've previously generated, because again, they're randomly generated problems that you can use. You might have also noticed that up here, another second output is a field called options, which basically gives you the options that have been in fact used in the problem generator, because as you remember, the function randomly generates all the options, so you have to, if you want to know what exactly happened, those is given as an optional output as well. In the last thing I want to mention is that if you don't specify either of those, so neither the class nor the size or combination thereof, so for instance, if you were to say I want to generate an mp-MILP, okay, with the sizes we just defined, so no size of binary variables, no number of binary variables specified, it will randomly pick a number between 1 and 20. So in this case, you can see here it had picked one binary variable. Now if we run this again, it picked 18 binary variables to be randomly generated. Okay, and so same thing with the problem class. If the problem class is not specified, then it will generate a random problem. In this case, it has generated a continuous problem. And if we were to look at this, so let's briefly do this, problem .q. So it has a positive definite Q matrix, which means we've now generated an mp-MIQP. Okay, and so this function is very fast, as you can see, very quick, and you can drive this to the extreme, where you can just say if you want any type of problem, you can just type in problem generator, enter, and it will give you a random problem. If you have any questions or any suggestions for the additional expansion of the problem generator, or any feedback or bugs, anything of this sort, please send us an email at paroc@tamu.edu, and we'll be more than happy to answer you back. Thank you very much.